All right, you guys, this is our final example in this section with trigonometric equations and inequalities. Okay, so this problem says solve tangent x plus square root of 3 equals secant x over the interval from 0 to 2 pi. Okay, so those same steps that we've been walking ourselves through this whole section, you want to check to see if the equation or inequality you've been given is linear or quadratic. Then you want to see how many trig functions are in your problem, see if you can separate them and use any algebraic techniques that you need in order to solve. So the first thing I'm going to do, as always, I'm going to write out my problem. Okay, when I look at this problem, it appears to be linear. I don't see any powers greater than 1 in any of my trig functions. All right, so then I want to see, well, how many trig functions do I have? Do I have different types of trig functions, or do I only have one? So when I look at this equation, not only do I have tangent, I also have secant. So that's two different trig functions that I have to deal with. The second thing is you want to see if you can split the functions up legally. All right, remember, don't make up math here. So our two functions are on different side of the equal sign. Secant's on the right, tangent's on the left. So they're separated, but I can't simplify them any farther than what they are. So I can't get my equation into terms of one trig function. So my next bet is, can I make a substitution in such a way that when I substitute, I will only have an equation that has one trig function in it, okay? So if you guys remember your trig identities, okay, you happen to have a Pythagorean identity. Okay, your Pythagorean identity says 1 plus tangent squared x equals secant squared x. Okay, now the reason why I chose that identity is because I needed an identity that dealt with both tangent and secant, because those are the trig functions that are in my problem currently. And I also needed an identity that I could substitute one of those trig functions for the other. So the Pythagorean identity says anywhere I see 1 plus tangent squared x, I can replace it with secant squared x, or vice versa. If I see secant squared x, I can replace it with 1 plus tangent squared x. Okay. Now, as we're looking at the identity and we're looking at the trig functions that are currently in my equation, the main thing that's different is that the identity has powers of 2 in them. Okay. My current problem doesn't have any squared powers in it. So the only way I can make the substitution is that I have to make my current problem have something that has powers of 2's in it so that I can use the identity to substitute. Okay. So the way that I'm going to fix that, I'm going to square both sides of my equation. All right. When I do that, okay, this left-hand side, all right, this is a binomial, okay? So because it's a binomial, it means that I have to use FOIL if I want to multiply this out. Don't forget, don't just distribute the squared power to the tangent x and the square root of 3. Remember, you have to FOIL it. So when I do that, I end up with tangent squared x plus 2 square root of 3 tangent x plus 3 equals secant squared x. Okay, so I've completely multiplied out my problem. Now here on the right-hand side of my equation, I see secant squared x. Because of the Pythagorean identity, anytime I see secant squared x, I can make a replacement. I can replace it with 1 plus tangent squared x. So that's what I'm going to do to make sure that all of the trig functions in my problem are now aligned and they are all tangents. So I'm going to rewrite. Okay, so now I have this. Now, two things have changed in my problem since I've done this. The first thing is, all right, I made a substitution. Okay, so I need to make a note that I made a substitution. Okay, because I made a substitution, at this point, I have to remember that when I'm done with this problem, I'm gonna need to check my answers to make sure that they make my equation true. Anytime you do a substitution, you're going to have to make sure that you do that. So I'm going to make a note to myself to check my solutions when I'm done. Okay. The other thing that changed is that now I have an equation that are raised to the second power. Now I have these squares in here, okay? Which means that I need to treat this now like a quadratic equation because I made the substitution. All right, so because it's quadratic now, I'm going to set it equal to 0. So for me, anything that's on the right-hand side of my equation, I'm going to move to the left-hand side. So I'm going to subtract the 1 and this tangent squared x. I'm lining up my terms on the left-hand side. And I'm going to combine like terms. So this tangent squared x and minus tangent squared x, they're gone. They cancel. I'm left with 2 square root of 3 tangent x plus 2 equals 0. Okay. So when I set everything equal to 0, the squared terms took care of themselves. They canceled out. So I no longer have to worry about this being quadratic. And now I only have one trig function. So it's linear. I can solve this like I normally would a linear equation. So my goal is going to be to get x by itself. So I'm going to move this 2. I'm going to divide by 2 square root of 3. All right, that's going to give me tangent x equals, the 2's are going to cancel. Just going to give me negative 1 over the square root of 3. Okay. And the next thing I'm going to do is you can either rationalize this here. Actually, let's do that. All right, so if I rationalize this, I need to multiply by square root of 3 over square root of 3. So it's going to give me tangent x equals negative square root of 3 over 3. And then that x, remember you're solving for x, but it's embedded in our trig function. The only way it can come out is if you do the inverse. So let me draw this arrow. So we're going to say x is equal to inverse tangent of negative square root of 3 over 3. Okay. So what that's telling me is that I'm looking for angles on the unit circle that give me a tangent value of negative square root of 3 over 3. Okay. So if we slide over here and we look at our unit circle, pick this up. All right. Now remember, tangent, in terms of your coordinates on the unit circle, tangent is defined, okay, as y over x. So remember, you're not necessarily going to see this value, negative square root of 3 over 3, directly from the unit circle. You're going to have to divide the x and y coordinates to find it. So once we do that, we see that our answer should be 5 pi over 6. So let me get my highlighter. It should be 5 pi over 6 and 11 pi over 6. Okay, so because this tangent value was negative, okay, we know that tangent is negative in the second quadrant and the fourth quadrant, so I already knew there. And when I divide the y over x, that gives me negative square root of 3 over 3. Okay, so those are my two answers. Now, before I can accept these, because I made a substitution, don't forget, we have to check to make sure these solutions actually work in our problem. So what that means if they work, it means that if we plug 5 pi over 6 and 11 pi over 6 into our original equation, it should give us the same answer on both sides. All right, so let's do that. Let's check our answers. All right, let me change my pen color. All right, so we're checking our solutions. The two answers we got were x equals 5 pi over 6 and 11 pi over 6. So I'm going to check 5 pi over 6 first. No reason, just checking it first. All right, so that means that I'm going to plug 5 pi over 6 into my equation everywhere that I see an x. So that's tangent 5 pi over 6 plus square root of 3 equals secant 5 pi over 6. Okay. Now, you can either do this by hand or you can plug it in the calculator. Okay. It's completely up to you. All right. When you plug this into the calculator, the right-hand side and the left-hand side, they are not going to be equal. Okay. This is not true. So 5 pi over 6 is not an answer. So you have to exclude it. 5 pi over 6 does not work. Okay. When you go to try 11 pi over 6, okay, you do the same thing. Tangent 11 pi over 6 plus square root of 3 equals secant 11 pi over 6. When you plug the left-hand side into the calculator and you check the answer and you plug the right-hand side into the calculator, both of these sides will equal each other. It will be true, okay? Which means that 5 pi over 6 was your extraneous solution. It's a solution you had to toss out. And 11 pi over 6 is the only answer that worked, okay? So for this particular problem, you only have one solution, and it's 11 pi over 6, okay? Now, don't forget, this is one of those special types of problems. So anytime you make a substitution, okay, you're going to have to do what we just did. You're going to have to check to make sure that your solutions make your problem true, okay? If all of your solutions make it true, then you get to keep them. If some of them make them false, you have to throw them out. They're called your extraneous, all right? So don't forget. Well, that's it for that section.